Hey everyone, welcome back to the channel. In this series, we are going to explore one of the most powerful and commonly used features in Java, the static keyword. We will break it down step by step, covering everything from static variables and methods to static blocks and nested classes. This playlist will help you understand how static works and why it's an important tool. In today's first part, we will start with the basic introduction, what static means and where it can be used. In Java, static is a keyword used to indicate that a particular member, that is variable, method, block, or nested class, belongs to the class itself rather than the instance of the class. Now, before moving further, we will see the memory allocation of static variables before JDK8. So, before JDK8, the static variables were stored in a segment called as permanent generation, or in short we called it permgen. This segment was attached contiguously to the heap segment, that is like this. See, this is the heap memory, that is the heap segment, and the static variables are stored in permanent generation. In short we called it permgen. So what was the disadvantage of this? The disadvantage over here was that the memory, that is permanent generation, was fixed in size. That is, it was fixed at 64 MB for 32-bit OSs and 82 MBs for 62-bit. So this was the disadvantage. Now, from JDK8 onwards, the memory allocation of static variables was inside the native memory. So where is the native memory? We call the native memory as the RAM. Inside RAM, a space is created that is known as meta space, and the static variables are stored inside the meta space. So this is what it looks like after JDK8. The space, that is meta space, is dynamic in nature, that is, it grows or shrinks. Now, coming back to the definition of the static keyword, over there, I have mentioned that the static variables or the members that are static in nature belongs to the class and not to the instances. So to understand this clearly, we will see a code that will count the number of objects created. Now we will create two classes. One will be for running the code and another class I will name it as child, will be class child. In this, I will make a instance variable that is of type int, and the name of the variable will be count. Now, whenever we create an object of this child, this count should increment. So for that, I'll be using the constructor. Now, whenever the object is created, this count will be incremented. So let's see. We create an object of child. I will name it as child1. I will create another object named as child2. So I have created two objects. So the count should be 2. Let's see. But how to print the count? We need we need to use the references. So we will print the count of the object. Now we will run the code. While running the code, got the answer as 1. Let's print the count of child2. Child 1's count is also 1 and child 2 is also 1. Now, what we needed? We needed to count the number of objects created. But over here, we are not getting that. So I will just add static keyword over here. Now, see over here, a warning is shown. That is, we should always access the static elements or static members using the class name. So over here, our class name is child. So I will call the count the child. Now let's see what happens. We got the result. Two objects are created and over here we get 2 as the answer. Now, why did this happen? As in the definition, I told you that the static keyword belongs to the class, not to the object. We will see this using the memory diagram to better understand the topic. Now, we will see the memory diagram of the first code, which didn't have the static keyword. So, when we run the code, two memory segments will be populated. That is heap and meta space. So when we create the object of child 1 and child 2, they will be placed inside heap. Now suppose this one is child 1 and this is child 2. They will have the count variable, that is count over. At first, both will be initialized to 0, and when the constructor increments it, the value will be incremented from 0 to 1. And same goes in the case of child 2. Therefore, we got the answer as 1 and 1 when we called the count of both the objects. So this was the issue. We were getting the count of each object. Now to count the number of objects created, we made the count as static. So we know the static members are allocated the space inside the meta space. This was when int was not given as static. Now in the second code, we made int as static. Since the count was static in nature, it was allocated the space inside the meta space. It is over here. And the initial count will be. So when we created the first object, that is child 1, the constructor incremented the count, that is this count. And when we created the child 2 object, this count was only modified to, therefore it was showing as 2. And we got the result as 2 for both the objects as we created two objects. Now from here we can see that the static variable or the static members are class level. That is, for each class there will be only one static member. Okay, that is why it is called as class level. Please subscribe to the channel to see the updates. Thank you.